In Chapter 13, you're being guided through the calculation of an analysis of variance. Now, as you know by now, the analysis of variance is going to be comparing the differences that are observed between groups, in this example, between three groups, as compared to all of the variance that you observe within groups. And as with all of your previous tests, you need a critical value. And of course, you have to identify the critical value before you start your data analysis. For the ANOVA, the distribution that's used is referred to as the F distribution, and this is explained in more detail in your text, so please look at that. I hope you've printed out this table by now. If you haven't printed out this table, please do so before you continue with this example, with this video example. So let's look now at the F distribution table. As you can see, this is the critical values of the F distribution for alpha equals 0.05. And the far left column has degrees of freedom within, going down the far left column, and across degrees of freedom between. So obviously, with an ANOVA, you need to calculate these two different types of degrees of freedom, right? Previously, because we were only comparing two groups, we only had one type of degrees of freedom we were concerned about. But now, we have to distinguish between the degrees of freedom within, which is abbreviated WI, versus degrees of freedom between. And for a different calculation, for a different step in the process of calculating the ANOVA, you will need to know degrees of freedom total. And calculating this separately from these is also a very good check to make sure that you've calculated these correctly. So to determine degrees of freedom within, it's simply the sample size, and as we said in the text, for an ANOVA you use capital N to indicate the entire sample and small n to indicate the subgroup sizes. So here in the example in your book we have an N of 30, and K of course equals the number of groups. We're comparing three different groups. So this is the total sample size minus the number of groups. So if N equals 30 in our example and number of groups is 3, degrees of freedom within is 27. Degrees of freedom between is calculated K, which is the number of groups, minus 1, and you probably recognize that. And so if we have 3 minus 1, that's 2, so degrees of freedom between is 2. And then if we add these, it's 29, and we can do a second check and say big N, 30 minus 1 equals 29. So we know we've calculated our degrees of freedom correctly. So let's say that and you'll see that in your table 3 that's in your book, and again please print this out now. Table 3, the first page gives you critical values for 0.05, the second page gives you critical values for alpha equals 0.01. So let's say we're going to go with alpha equals 0.05, and we simply go down and identify 27 here, and we see that on this table 27 falls between 26 and 28. Not every single value is given after the value of 20. So you'll interpolate slightly. And degrees of freedom between, as we said, is 2. So go to the column for 2. Here, degrees of freedom between is 2. Go down to the row, equivalent to degrees of freedom within, which is 27. And you'll see that our critical value will fall someplace between 3.37 and 3.34. Right? Okay, and so equidistant between these two marks, we see that we have 4, 5, 6, right? So the exact value here would be 3.35, if you want to say that. 3.355 would be exact, but you can round it and you can say 3.6 would be fine to use for that.